This is the sixth in a series of resources on integral calculus. We define the idea of an integral. We investigate the fundamental theorem of calculus and look at some basic rules for integrals. We explain the difference between definite and indefinite integrals, looking at a basic example. We consider using Riemann sums as a method for approximating a definite integral. We investigate the integrals for specific function forms, including polynomials and trigonometric functions. We will also look at substitution methods to simplify certain integrals. In the resource on polynomials, we realize that the integral of x to a power n with respect to x is equal to x raised to the power of n plus 1 divided by n plus 1. This rule can be generalized to any differentiable function u. This leads us to a method to solve certain integral problems called u substitution. The first step for u substitution is to determine what function is being raised to a power. Next, we take the derivative of the function u with respect to x, or whatever variable we are using. We will have some du equal to some function of x multiplied by dx. Solve this equation for dx. Substitute into our original equation. We should have the integral of some constant multiplied by u to a power with respect to u. Perform this integration. Simplify the remaining function. Replace u with our original variable expression. Let's see a couple of examples. For example, suppose we want to find the integral of the quantity 3x plus 7 raised to the fifth power with respect to x. This is a perfect setup to use u substitution to find the integral. We need to identify our choice for u, or what exactly is being raised to a power. In this problem, we have the quantity 3x plus 7 raised to a power, so this will be our choice for u. The derivative of this function will be 3 multiplied by the derivative of x. Solving for dx, we have 1/3 multiplied by du. Substituting into the integral, we now have the integral of u to the fifth power multiplied by 1/3 of the derivative of u. Since the 1/3 is a constant, we can factor that out in front of the integral and are left with 1/3 the integral of u to the fifth power with respect to u. Integrating, we have 1/3 multiplied by u to the sixth power divided by 6. Because we are completing an indefinite integral, we cannot forget our plus c. Simplifying, we are left with 1/18 of u to the sixth power plus c. To finish, we substitute the original expression back in for u. We have 1/18 the quantity 3x plus 7 raised to the sixth power plus c. Let's look at one more example. Suppose we want to find the integral with respect to x of the square root of the quantity 4x minus 1. Again, we are set up to calculate the integral with u substitution. Our selection for u is the expression under the radical 4x minus 1. Its derivative with respect to x is 4 multiplied by the derivative of x. Solving, we have dx equal to 1/4 du. Substituting in, we have the integral of the square root of u multiplied by 1/4 multiplied by the derivative of u. Adjusting, we have 1/4 of the integral of u to the 1/2 power multiplied by the derivative of u. Taking the integral, we have 1/4 multiplied by u to the 3/2 power divided by 3/2 plus c. Simplifying, we are left with 1/6 multiplied by u to the 3/2 power plus c. Substituting the original expression back in, we are left with 1/6 multiplied by the quantity 4x minus 1 raised to the 3/2 power plus c.